easier na lang to explain in video. So, in the example in the GC, it looks like this, right? Hold on. In the example shown in the GC, the thing looks like this. So, plus 2n 2n2 to this. Okay, so this is what you're seeing in the GC. Now, just remember that there will always be three given things in the question. So this, like, there will always be given of these two, and another given that you ignore until percent yield, which is 2.89. All right, this. All right, but we can ignore this for now. We need to focus on limiting Reagent. So the way you do this is pretty simple. You just take this, like one of the variables, right? So, and then on the bottom, you write down the molar mass of each element. So, for example, like silicone is like the molar mass of silicone is 28.08, and the molar mass of nitrogen is 14. However, what you need to pay attention to is that it's referring to N2. So it's 14 times 2, which is 28. All right? After that, you can just divide it. So here, 2 divided by 28.08 would be 0.071, and like 1.50 divided by 1.50 divided by 28 would be 0.054. Okay, once you have those two, it's not confirmed yet whether or not this is the limiting region or this is the limiting region. So what you do now is times it by like these variables, okay? So remember that since this is silicone, this is your N2, okay? Remember that if once you're gonna times it now, you're gonna double check. This is the double checking process. Once you're gonna double check this, the silicone part will always be at the bottom. So since our variable is 3SI, you're gonna write 3SI here, and then your other variable will be nitrogen. This is just for double checking, okay? So, like again, you times this by the top number. So 0.071 times 2 would be like you times like of course like times it by the top number, which would be 0.142 divided by 3, and then you'll get like 0.047, okay? And then after which you do the same on the other side, except you always remember that the variable that you're gonna choose, all right, since like this is nitrogen, nitrogen will now be on the bottom. So this is your 2N2, and then this is your 3SI. Okay? So again, it's like 0.052 times 3, and then divided by 2. And then, oh wait, I think I did it wrong. 0.04, oh wait, 0.054 times 3 divided by 2. Okay, 0.081. So that should this is what it's supposed to look like. And as you can see, your what is this? Silicone actually runs out faster because it's lower, right? So this is your limiting reagent, and then this is your excess reagent. Okay, so now we're done with the limiting reagent process. We already identified that. We can now move on to the percent yield. So percent yield, what you need to do now is plug these two in. So it should look like this, where it's 0.071 and 0.054. So you take, of course, your limiting reagent, which is silicone, and your excess reagent. Okay, so once you've done that, you times both by this. Okay, this is now what you're gonna times it with. So of course, um like since this is like si3 and like, what is this, si3n2, and this is like also si3n2. Okay, once you do that, take note that since like there's always an invisible one here, okay, that like works for anything, that works for like any compound. So if this were just like si, there's all the value is always 1. And if it says like example, like just in case if it comes out in the exam, because I forgot the question there, just in case if it like there's like a number here like, oh, like 2 si and 2, like 2 si3 and 2, then you like do the same process. So just remember there's always a 1 here. If it what like there's always a 1 there, and if it changes to like any other number, you just proceed as normal. So now what you're gonna do is also write these two down at the bottom. So write your like variables at the bottom as well. So your 3si and your 2n2. Okay, write those at the bottom. And now you just multiply 0.071 times this. Okay, so it should be 0.071 times 1. All right. Okay, so times 1 divided by 3. Okay, always remember that like over here it's just like times the top number, divide by the lower number. Okay, so like you multiply by the top, divide by the bottom. So 0.071 divided by 3. That would leave you with 0.024. And then you take the other one as well and do the same thing. 0.054 times 1, like times 1 up here, divided by 3. And you would get, okay, wait, what the hell? 0.054 oh wait, no, not divided by 3, divided by 2, my bad. Divided by 2. All right, 0 point equals to 0.027. Okay, like always remember, multiply by the top, divide by the bottom. And then now what you do now is take the lowest number, so in this case 0.024, and now you're gonna find the theoretical yield, which is always 0.024 times. And now here's the thing, you need to find the the total atomic weight of both of these. Okay, so what that means is that we're gonna take like 28, okay, from earlier, 28.08, right? which is the atomic, like the molar mass or like whatever of silicone, and then times it by 3. So keep that in your head. 84.24. Actually, here, I'm gonna write it down. 84.24. Okay? And then that goes the same for N2. So if it's like, oh yeah, wait, no, it's not N2, it's N4. My bad. My bad. But like that doesn't matter. It didn't matter in the equation anyways. So now you have to take the atomic weight of N4 over here, which is if let me check. Yeah. So it's 14 times 4, which is 56. So now you have to just add those together. So 84.24 plus 56, which will add up to 140 point 24 grams. Okay? So you get the 140, you plug it here. 0.24 grams. And then it's always like the 1 mole of Si3 and 4. And I'm pretty sure it doesn't like change because like you write mole, okay? It's like you write mole there, so it's always like gonna be above 1. So 0.024 times 140.24, okay? And like, oh, what is this? That's gonna be times 0.024 times 140.24 divided by 1, because it's like 1 at the bottom, but like it doesn't matter. 3.37 grams. And this is your theoretical yield. Okay? So now, remember that number from earlier that we ignored. This, you take that number, 2.89 grams. Okay? You put your theoretical yield at the bottom. And then you times by 100 to get the percent yield. So, 2.89 2.89 divided by 3.37 times 100. And as you can see, we get 86%. And this is proven because that's also the product here. Okay? So yeah, this is correct. Okay, always remember you have 3 givens, in these questions, okay? Both of these givens and the given that you ignore until percent yield. So always remember that you use this as your limiting reagent. It will ask for your limiting reagent, and then this is your theoretical yield. Okay? And that is it. That's everything.